Bismillahirrahmanirrahim. Assalam O Alikum, dear students. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus National Book Foundation Physics SST 2. In unit number 10, simple harmonic motion and wave. SLO base or FAISC requirement numerical problems question number 5 to 7 in part 2. In previous part we can solve the numerical problem question number 1 to 4. In this video we can solve question number 5 to 7. In question number 5, if 10 waves are produced on a long stretch string of a length is 1 meter, what will be the length of wave and what will be its frequency of wave? If the speed of wave is 12 meter per second. First of all, according to the given statement, write the given data. Given data, number of wave n is equal to 10 and speed of wave v is equal to 12 meter per second. Now distance is equal to the length of string, so distance is equal to L is equal to S is equal to 1 meter. Now required that frequency f is equal to question mark and the wavelength lambda is also equal to question mark. Now we using the formula, we know that V is equal to f lambda. Then f is equal to number of wave divided by time. And we can also find the time. So V S is equal to Vt and T is equal to S upon V. According to the distance equation, S is equal to Vt. Then, first of all, find the time. T is equal to S upon V. Distance over speed. So, distance is equal to 1 and speed is equal to 12. Then time t is equal to 1 upon 12 seconds. Now we can find the frequency. According to the definition, frequency is equal to the number of wave with respect to its time. Then number of wave is equal to 10 and time t is equal to 1 upon 12. Third ratio multiplied on other side, so 10 multiplied by 12 is equal to 120 hertz. We know that V is equal to F lambda. Then lambda is equal to V upon F. So value of wave speed V is equal to 12 and frequency F is equal to 120. Then lambda is equal to 12 divided by 120 is equal to 0.1 meter. So the result frequency f is equal to 120 hertz and wavelength lambda is equal to 0.1 meter. Question number 6. In question number 6, given statement in a ripple tank of a length is 1.6 meter. Wave covers this length in 2 seconds. So time period is equal to 2 seconds. If the distance between the two consecutive troughs is 20 centimeters, the distance between the two consecutive crust or trough that is equal to the wavelength. So this value is equal to wavelength. Wavelength is 20 centimeters. Then find the number of wave, frequency of wave and also find the time period. Now write the given data, the distance between the two consecutive terms. So that is equal to the wavelength. Wavelength is equal to lambda. Lambda is equal to 20. 20 centimeters change into meters, then 20 divided by 100 is equal to 0.2 meters. Now, since the wavelength travels the distance 1.6 meter in 2 seconds, so the velocity We can find by the formula wave speed v is equal to distance upon time. So wave speed is equal to v is equal to distance upon time. Distance is 1.6 meter and time is 2 seconds. Then v is equal to 1.6 divided by 2, that is equal to 0.8 meter per second. And also given that time t is equal to 2 seconds. Now we can find the frequency f, and we can also find the number of wave n, and find the time period capital T is equal to question mark. First of all, write the solution. We know that V is equal to F lambda. Then F is equal to V upon lambda. So F is equal to 0.8 divided by 0.2. Frequency F is equal to 0.8 divided by 0.2, that is equal to 4 Hertz. Now the time period is reciprocal of frequency. So capital T is equal to 1 upon F. That is equal to 1 upon 4. Now 1 divided by 4 is equal to 0.25 seconds. Now we can find the number of waves. Number of waves is equal to frequency multiplied by time. So the frequency is 4 Hertz multiplied by time is 2. 4 2s are 8. So the number of waves is equal to 8. Result, frequency f is equal to 4 Hertz. Time period t is equal to 0.25 and number of wave n is equal to 8. Now in the last question, calculate the frequency of red light. Wavelength is 700 nanometer in vacuum. First of all, write the given data. Wavelength lambda is equal to 700 nanometer. Now 700 multiplied by 10 raised to power minus 9 meter. Then we can write that 7 multiplied by 10 raised to power 2 multiplied by 10 raised to power minus 9. Bases are same, then power will be added. So 7 multiplied by 10 raised to power minus 7 meter. And velocity v is equal to velocity of light. So 3 multiplied by 10 raised to power 8 meter per second. We can find the frequency f. So using the formula v is equal to f lambda. Then solution v is the velocity of light, 3 multiplied by 10 raised to power 8 meter per second, and lambda is the wavelength and f is the frequency. So putting the value, then f is equal to v upon lambda. Value of v, 3 multiplied by 10 raised to power 8 divided by 7 multiplied by 10 raised to power minus 7. Here 3 divided by 7 is equal to 0.42. 10 raised to power 7 move upward, then power will be positive. 8 plus 7 is equal to 10 raised to power 15. So frequency is equal to 0.42 multiplied by 10 raised to power 15 Hertz. That is equal to 0.42 picohertz. Then final result of frequency is equal to 0.42 multiplied by 10 raised to power 15 Hertz. Best of luck.